The diagram shows sector OACB of a circle with centre O. The point C is the midpoint of the arc AB. And the diagram also shows a hollow cone with vertex O, and the cone is formed by joining OA and OB. Okay, so there's a lot going on there, so let's break that down a little bit. Essentially, we've got these two shapes here. So this shape here, if we take this length here and this length here, and we sort of bring them together, that creates this cone shape here. Now the cone has a volume of 56.8 centimeters cubed and a height of 3.6 centimeters, and our goal is to calculate the size of angle AOB of sector OACB. So essentially we want to work out the size of this angle here. So we've been told the height of the cone. So if I put that on here, it's going to be 3.6 centimeters. So we've used this one here, and now we've also been told that the cone has a volume of 56.8 centimeters cubed. Well, we've been told in the question the formula for the volume of a cone. So let's fill in what we know. Well, we know the overall volume is going to be 56.8. And we also know the height is 3.6. So now we've only got one unknown, this r squared here. So we can solve this to find out what the value of r is. So firstly, if I do a third multiplied by 3.6, we're going to get 1.2. And then still our pi r squared here. Now if I divide both sides by 1.2 pi, we'll see all of this cancels on this side. I'm going to write it the other way around to make it a bit clearer. Essentially we're left with r squared by itself equals 56.8 over 1.2 pi. Now last but not least, we can square root both sides, giving us 3.882 if I write that to 3 decimal places. Fantastic, so now we can add that on to our diagram up here. So the radius is this bit here, and that's 3.882 centimeters. Now using this information we can find some more. If we have a look here, we've created a right angle triangle. So I reckon we can use Pythagoras to find out this length here. Now Pythagoras' theorem says that a squared plus b squared is c squared. And I reckon we can work out what c is by doing 3.882 squared plus 3.6 squared, and that equals c squared. So popping this into the calculator, I'm going to write it the other way around actually. We're going to say c squared is 28.030 to 3 decimal places. So square root of that is 5.294. Fantastic, we've got some more information we can put on now. So we've got that this length here is going to be 5.294 centimeters. Now what's next? Well, we're told in the question that the formula for the curved surface area of a cone is equal to pi RL. So in our case, we're going to have, that's pi, and this is R, so 3.882, and this is L, so 5.294. So that gives us, again, if I round to 3 decimal places, we're going to get 20.551 pi. So the curved surface area is all of this surface of the cone here. Because we've got this shape from this shape, that's essentially the same as this area here. So I might be able to recall that the sector area is equal to theta divided by 360 multiplied by pi r squared. Well, let's have a look at what we've got. So we've got, this is the radius here. But we actually know that because that's the same as this length here. So it's going to be 5.294 centimeters. And while the sector area is what we just worked out, it's 20.551 pi. So filling that in, we've got 20.551 pi equals theta, what we're trying to work out, divided by 360. We're going to multiply that by pi, and 5.294 squared. So I can see on both sides we've got pi, so I can cancel that. And if I multiply both sides by 360, I'm going to get 20.551 multiplied by 360 equals theta multiplied by 5.294 squared. If we divide both sides by this, we're going to get theta is 20.551 multiplied by 360 divided by 5.294 squared. And I'm going to just put all of this into the calculator very carefully. And that gives us 263.978 to 3 decimal places. Well, we want the answer to three significant figures. So that's going to equal 264 degrees to three significant figures, which is our final answer. We get our first mark here for substituting what we know into the formula, and the second mark for getting down to here where we've worked out a value for r. We get our third mark for using Pythagoras here to get a value for c. We get our fourth mark for forming this equation, and the fifth and final mark for the correct answer of 264 degrees.